Yeah, what's up, guys? I hope you're well. Yes, so today we're going to look at creating a function or formula to calculate the determinant of a matrix, of a 3 by 3 matrix. So we're going to use Sarrus rule, okay? The rule of Sarrus, as they say anyway. So yeah, on a side note, guys, I'd really appreciate it if you do subscribe to my channel. So if you love what you see, please do subscribe. Please do share the videos with your friends. I'd really appreciate that. Okay, cool. So let's get started. So I need to import the library that I need. So before I do that, actually, let me type the stuff that we're gonna do. So calculate a determinant of a 3 by 3 matrix using the rule of Sarrus. Right. Yeah. So I need to import the library. So from then SymPy import star and issue init printing. Yeah, so pretty print because true, right? Okay, and so I just got a matrix. I'll set my matrix to a variable m, capital M. So matrix, right? So that's 1, 0, 4, and then minus 2, then 1, then 0, and then 3, 5, 7. Right, so that's my matrix M, right? So the rule of Sarrus. So I'll just show you something here. What I'll do is I'll define symbols. So A, and D, and C, D, E, F, G, H, and then I. So that's equal to symbols. So A, B, C, D, E, G, H, then I. Right. So I'll just create a little matrix M, small letter M, right, and then matrix, right. So A, B, and then C, right, and then that would go back to A again, and then B, and then D, E, and then F, then D again, then E again, right, and then finally G, H, and then I, then G, H again, right. So M, right. So so the rule of Sarrus, what it does is you take out the first two columns and then put them on the side, or create another matrix. So that would be a 3 by 5. Yeah, so 3 rows and then 5 columns, right? So then what you do is these diagonals, so G, E, C, right? And then H, F, then A, then I, D, B, right? So what we'll do is with these ones, these will be, you'd subtract these diagonals from these diagonals. So A, E, and I, and then B, H, and G, and then C, D, and H, right? So these diagonals, right? There you add these 3 diagonals together, then you subtract from these diagonals. Yeah. Okay. Hopefully I'm making sense, right? So what we'll do now is create a function, right? So define, then Sarrus, right? A, then B, and then C, and then D, and B, C, D, E, and F, G, then H, then I, right? So then return, right? So A times E, 8 times I, right? So that A times E times I, right? Right, and then we add the next diagonal, so B, F, G. So B times F, sorry. So B times F times G, right? and then add the other diagonal as well. That'll be CDH. So C times D times H. So C times D times H, right? And then we subtract, right? So we're gonna subtract the other diagonal. So G times E times C, right? And then H, F, and A, right? So H times F times A, right? And then the final one, so IDB. So I times, no, sorry. So I times D times B. Right, so return now. Okay, so that's our matrix there. So we're gonna test that. So Sarrus, right? And so that's gonna be A and then B and then C. Okay, so 1, 0, and then 4, right? And then -2, 1, 0, and so forth. -2, then 1, and then 0, and then finally so that's the G and H and I. So 3, 5, 7, 3, 5, and then 7, right? Okay, so here we are. So that's -45, right? So what I'll do again, I'll just copy that, Command copy, and paste that in there. Is that equivalent to the determinant of M.det? Bravo, true. So there we are. So obviously, like, even if I do that, okay, I mean, just do that a formality, but I don't have to do it. But yeah, it's -45. Yeah, cool. So yeah, that's how you'd create a function to calculate the determinant of a 3x3 matrix using the rule of Sarrus. Yeah. So if you find this very helpful, guys, like I always say, please do subscribe and please do share the videos with your friends. Yeah. So cool. So have a lovely one. Cheers. Bye bye.